Hi, Julian here from PopcornFX. Today I will show you the mesh importer and the new things that we added in 2.6. So the first thing that jumps to the eye is that we added a bunch of panels. Let's go through them one by one, even the older ones. So here in the viewport we have a bunch of controls to capture the thumbnails in the content browser, this little camera icon, like in the other content editors and the effect editor. This button here resets the view, so if I move away and click here, it resets it to the default, so the mesh is entirely visible. You cannot yet in the mesh importer save the custom camera coordinates like you can in the effect editor, but that's something we'll add in later versions. Here currently the simulation speed slider is pretty much useless because we don't yet play back animated meshes. So we do have the ability to import meshes that contain animations. Here you see there is a skinning and we don't see it well, but here we have a skeleton and we'd say to import the animation and skeleton in that mesh, and there is actually an animation which we cannot yet preview in the mesh editor. So this is something that will come in a later version as well. Here you have a toggle to toggle the grid. This is to hide and show the mesh bounding box. Useful if you have multiple submeshes to make sure there isn't a rogue triangle somewhere. These enable the visualization of normals and of the tangent basis. So when you enable the tangents, it displays both tangents and bitangents, or binormals, however you prefer to name them. Note that this will do nothing if the mesh isn't imported with normals or tangents. So here let's say I enable both. If I disable tangents here and re-import, now I will only have normals even though I tell it to display tangents. Next up we have some render modes where you can toggle between different wireframe modes, and this is mainly a debug view which is not that useful in the mesh importer. You can view world space and view space normals. These basically show the different buffers used in the deferred renderer used by the editor. And this one at last pops the settings of the entire mesh editor, where you can configure a bunch of things. Next up is the asset details panel, where you see details about the mesh, how many triangles it has, whether or not it has an animation or a skeleton. So if we reopen that one, here you'll see it has 68 bones. And next you have the list of all the submeshes. So here I have only a single submesh, where I can see more details, the number of triangles of vertices, which vertex channels it has. So here I only have position, normal, and one set of UV coordinates. The number of indices, whether they are 16-bit or 32-bit, and the actual dimensions, world dimensions of the bounding box in world units. Well, not really in world units, in units, because my world units here are in meters, but when it's small enough it will display them as centimeters or millimeters. And finally, some information about the various data structures that are saved in the mesh. So here I have the sampling information saved, I have the KD tree used for intersection, which is also saved, and the UV to parametric coordinates, which is generated. And if I disable any of them, they will just be gone from this list. So for example, when I open a mesh which has multiple submeshes, such as this one, here you will see the bounding box be highlighted when I hover one of the multiple submeshes and the details of each submesh. For example, this one here is the only one in the list which doesn't have an UV coordinate. So hovering those submeshes, as I said, will highlight the bounding box. We don't yet dim the other submeshes to highlight the one currently being hovered, I mean highlight the geometry. That's also something we'd like to add in an upcoming version. It will also change the highlight in the UV panel. So you can't really see it well here because they mostly have the same UVs on top of each other. But if I open, let's say that one, you can see it a bit better. So it's still not very readable. We overlap the UVs on purpose in case you want to see how they correlate between one submesh to the other. If you want to see a UV set more clearly, you can solo a submesh, and here it will show you the UV set of only that submesh. Also, if I display the normals, so yeah, here I don't have a tangent basis, as you can see. I don't have the tangents, just the normals. So if I display the normals and hover, you will see that the normals of the other meshes are dimmed. It's not very, not that readable with all the geometry overlapping here. And if I solo, say that one, so now I just have the UVs of that submesh and just the normals of that submesh. So next up, the UV viewer panel, which we kind of just saw. So to show that, I will go back to the ring. Here it's a bit nicer. So as the name implies, it shows you basically the UV set of the mesh. The green limit here is the 0, 0 to 1, 1 UV coordinate limit. Here, if you have multiple UV sets in that drop-down, you will see them and be able to switch between them. I currently don't have any mesh which has multiple UV sets, so I can't really show that to you. And here, these are debug helpers for the UV to parametric coordinates acceleration structure. So in case you don't know what the UV to parametric coordinates structure does, I will quickly show you a very concrete example by opening that effect here. So what this effect does is basically use a texture to look up specific points on the mesh and spawn particles on those points. So here I have my ring mesh. I have my density texture, which, if I open it, you can see the markings here. They are in the blue channel. So here what we want to do is to basically sample spawn particles wherever the blue channel is non-zero. So this is exactly what this does, using the texture sample density node. So you wire the texture into that sample density node and it outputs a set of random UVs sampled on those non-black regions. And if you have grayscale shades, they will affect the probability of the samples to be spawned here, so you can have gradients with less dense or denser regions of particles being spawned there. So here, once we have that random UV, we wire it into the shape sample from UV node, which takes a mesh, takes a set of UVs, and it will return the position in that case, but you can also sample normal and other properties. You can get the parametric coordinates as well. So it will sample, it will return the position on the mesh where that UV set lies. So this allows us to do basically UV space sampling of a mesh. So this process here, the sample shape from UV, is what uses the UV to parametric coordinates data structure. So here, for example, if I remove the UVs and the mesh doesn't have any more UVs, you will see that the effect breaks because it needs mesh UVs, obviously, to do that lookup. Here it tells me that it failed sampling mesh from UV parametric coordinates. So these kind of messages, if you see them, these are internal simulation warnings that the effect editor pops. Also note that if you have UVs but uncheck the generation of the UV to parametric coordinates, this will give you a smaller memory footprint in appearance, because whenever you try to sample from UV coordinates in a simulation graph, the runtime will on demand generate the UV to parametric coordinates data structure even if the mesh doesn't contain it. So this can be because it will make the Popcorn runtime generate that on load when the effect gets loaded, so it can cause frame rate spikes, as it is somewhat expensive to build. And overall, this is very useful for performance, because otherwise you'd have to sample the entire mesh, get the UV on the random point you sampled, then look up the texture and instantly kill that particle if it was falling out of the texture region you want to spawn on. So this would mean that you'd have to spawn in that specific case here, you'd have to spawn like tens or maybe even hundreds times more particles, because compared to the actual mesh area, the area we are spawning on is very, very small. So of course you could always do a different mesh that just encloses those regions, but it would be a more tedious process, especially if you want this mesh to be changed dynamically in the game engine, and if you want that effect to stick on dynamic meshes, dynamic in-game meshes, you can't necessarily, from a workflow or production point of view, make a specific version of each mesh every time you want to use that effect on it. So let me put back the UV to parametric coordinates, and we were at those buttons here. So this one will basically show you the subdivisions of the acceleration structure, which is a quad tree. So here you can see where it recursed more. This can be useful to tweak the advanced settings here that control the way the tree is built, if you want to reduce that size, but it can pretty adversely affect performance. So as a general rule of thumb, keeping the default values is a good thing, I'd say. It's also possible we improve the generation of the tree in the future to make this smaller, so don't pay that much attention to it. And the one right after it here shows you the actual sampling performance depending on the region of the UV set. So this is directly linked to the actual depth of the tree, the number of triangles in each cell, etc. And it is an extremely good approximation of the actual runtime cost. And last thing is the benchmark mode. So similarly to the texture viewer and vector field viewers, where you also have a performance mode, benchmark mode, when you activate this and you hover the UV set, it will benchmark the actual simulation code that does that UV to parametric coordinate lookup and it will show you right below here the actual sampling cost. So this can seem a bit erratic, but if you zoom more closely, it really depends on which region you hover. So this is a pretty nice way to very quickly visualize the quality of the sampling. Quick side note here, if you don't like having the set of UVs visible when you activate this, you can change this value in the settings to make them disappear entirely. So here you just have the coloration based on the performance. And if I open, let's say that one, which is a much denser mesh, here you can see very expensive regions. Almost 200 cycles needed to sample that, and this is where the mesh density is very, very high, so the tree is deep and it's more costly. Also, while I'm at it, a quick side note here on the coloration of these two things in the asset details panel. You might have noticed in 2.6 we have some colorations going on, especially if you watch the vector field and texture viewer videos, where you can also see those colorations in the export and import windows especially. So these are asset budgets indications. This is something, as I was saying, new in 2.6. So this is basically project controlled. So in the project settings you can specify some specific budgets for textures, meshes and vector fields, giving medium and high limits that the editor will use to change the color of asset information, such as the memory size, the number of triangles in case of meshes. So here we have the triangles budget, medium and high. So this is way above the 15,000 triangles high, so it appears red. And if the project does not override these, there is also in the user settings, under performance asset budgets, these are the default budgets that the editor will use if the project does not override asset budgets. So this is still pretty experimental. There is a good chance that we iterate over this across multiple upcoming versions, and we'll do a proper video dedicated to asset budgets later on. So next up, we'll see the asset memory panel. This is a quick way to graphically visualize where the memory is spent or wasted in your mesh. So here we can see, for example, that the vertex buffer is actually not so big of a chunk in that mesh, and most of it is the UV to parametric coordinates. So if you have none of your effects that are using the UV to parametric coords or UV based sampling, you are just wasting memory here, so you can just disable that. It's disabled by default. So now we can see that we have the vertex buffer, which takes most of it, the index buffer is the smallest, and then we have the sampling lookup and the intersection lookup. Same here if you don't use particle intersections or raycasts with that mesh, there is absolutely no point to have this saved in the mesh, so you can just disable it as well. Note that these structures are expensive to build at load time. Next up, the bake settings panel. So this has been in the previous versions of the mesh importer, where you only had the viewport and the bake settings panel. We fixed a couple of bugs in 2.6 where if you disabled the text coordinates and the normals, it would basically be ignored in previous versions. So here you can really disable them, and now it's taken into account. Note here that I disabled the UV coordinates, but I still have the right UV to parametric coordinates acceleration structure. And this is totally pointless now because the runtime will simply not be able to use that at all. So if you have no UVs and you have this enabled, it will still be able to build it because it will build it from the UVs from the original mesh. But when the runtime loads it, it will be pointless. So you can just remove that if you remove the UVs. And here we have an interesting use case of some of those informations. Here that mesh is pretty massive. It's 24 meters high, which is pretty big for a wizard. So here in the big settings, I can change the import scale to have something more reasonable. Now it's 1 meter and 20 centimeters, so that's a bit small maybe. Right, 1 meter 90. With the hat, it's still a big wizard. And you have a bunch of advanced settings if you need to push this further. It's mainly configurations when building the various acceleration structures. And one last thing before wrapping up, I forgot to mention that for the normals and tangent basis buttons, you have the N and T buttons, which are shortcuts that you can use to quickly toggle them, like the RGBA buttons or keys in the texture viewer. And one more last thing I forgot to mention. I was showing this mesh during the video. This is actually a mesh from the Granny SDK. It's one of the default meshes they provide. So Granny from Rad Game Tools. So it's something we added in 2.5, version 2.5 of PopcornFX. The ability for the editor to load and display Granny meshes. So if your production is using Granny as a middleware, you can directly use the .gr2 meshes. You do not have to re-export to FBX for the editor to load them like before or like in V1. So here is another of their default meshes. And to set up that, because we cannot legally distribute the Granny DLL files, you will need to go into the user settings, and in the mesh editor settings, in the third-party category, you have a Granny path property where you will have to put the absolute path to your Granny SDK DLL, and once you fill that in, the editor will now be able to load GR2 meshes and display them and sample them. And that's it for this video. If you have questions, comments or suggestions, don't hesitate to post them in the comments section down below. Thanks for watching.